The other type of circuits are called parallel circuits. Parallel circuits, because if we draw them nicely, the resistors are literally parallel to each other. But really what happens in a parallel is there's more paths for the electricity to take. So the battery pushes, I'm going to go negative flow, the battery pushes electrons out, pushes the electrons in the wire, makes them go around. The way this one's drawn, they're going to be kind of going clockwise. When they get to this point, now the electricity has a choice. Some of the electricity will go up and through that resistor. Some of the electricity will go straight ahead through that resistor. Some of the electricity will go down through that resistor. Maybe you've heard the phrase path of least resistance. That's exactly what the electricity will do. Whichever resistor is smaller, let's say the straight ahead was the easiest path, more electricity would go that way. This is the opposite of a traffic jam. This is, imagine it's the end of our class and we're all leaving. So maybe the junction is we get to a point in the hallway and some people go one way down the hallway to get to their parking lot. Other people got to go the other way to get to, I don't know, the bus stop. And then a few people actually, maybe you're going up a bunch of stairs so you can pick up something out of a locker. The up a stairs pathway, probably not a lot of people are going to do that. So there'd be fewer amps going this way. A lot of people may be walking out the door to get to their car, so more amps going this way. And maybe only a couple people are taking the bus, so a few amps going that way. If there were 30 people in our class, 30 amps getting to that point, then the split up has to kind of match the 30. Maybe 5 people go upstairs, 10 people go to the bus stop, 10 and 5 make 15, so that means there's 15 people left that have to go that way. That's what a parallel circuit is. Generally speaking, a parallel circuit, because there's the choice, it makes it easier for the electricity to move around. You'll see that when we work through our numbers. It overall reduces the equivalent resistance. It's the opposite of a bad traffic jam. You get to a point and cars are going all sorts of directions, so everybody can speed up because some cars go one way, other cars go the other way. Generally, it's an easier thing to work around. The equation for equivalent resistance for parallel is a little bit more complicated. There's a proof that comes out of Ohm's law, but basically it's a fraction thing. The overall total resistance, R total, 1 over R total is 1 over R1 plus 1 over R2 plus 1 over R3. So the math will be a little bit more involved. We'll have to do some common denominator work, but we'll solve for RT and then just think through those current rules and loop rules to figure out what's going on in the circuit.